So I thought I would kick off today by actually reading an article that I saw on Hacker News the other day that is kind of relevant because it's about the kind of workflow that this person uses with Claude Code. And one thing that I found quite frustrating the other day when we started using Claude Code and Specify was that it would basically just ignore a lot of the instructions. And part of what I want to do with these streams and kind of starting with these simple little projects is understand the kind of workflow that is required using these AI tools to build good software and how to actually get the most out of the tools rather than just what I've currently been doing, which is basically just typing in to the prompt and then letting the agents do its thing. So this article is by Boris Tane and it's called How I Use Claude Code. Let me just make it a bit bigger so hopefully it's easier to read. Okay, so I've been using Claude Code as my primary development tool for approximately 9 months, and the workflow I've settled into radically different from what most people do with AI coding tools. Most developers type a prompt, sometimes use plan mode, fix the errors, repeat. The more terminally online are stitching together Ralph loops, MCPs, gas towns, remember those, etc. The results in both cases are a mess that completely falls apart for anything non-trivial. And yeah, I mean, that kind of aligns with my current process. I basically type into a prompt. And he's very right. I mean, anything that is basically slightly difficult ends up kind of falling apart, and you either have to get involved yourself and fix the code or just kind of go on this crazy prompting loop that ends up in a lot of frustration and a lot of burnt tokens. The workflow I'm going to describe has one core principle: never let Claude write code until you've reviewed and written a plan. The separation of planning and execution is the single most important thing I do. It prevents wasted effort, keeps me in control of architectural decisions, and produces significantly better results with minimal token usage rather than jumping straight into the code. So the approach here is the research phase, plan, annotate. It looks like he repeats that for 1 to 6 times. Then the to-do list, implementation, feedback, and iterate. Phase 1, research. Every meaningful task starts with a deep read directive. I ask Claude to thoroughly understand the relevant part of the codebase before doing anything else, and I always require the findings to be written into a persistent markdown file, never just a verbal summary in the chat. Read this folder in depth, understand how it works deeply, what it does, and all its specifics. When that's done, write a detailed report of your learnings and findings in research.markdown. Study the notification system in great details, understand the intricacies of it, and write a detailed research.md document. Write everything down, just know about how notifications work. Go through the task scheduling flow, understand it deeply, and look for potential bugs. There are definitely bugs in the system, as it sometimes run tasks that should have been cancelled. Keep researching the flow until you find all the bugs. Don't stop until all the bugs are found. When you're done, write a detailed report of your findings in research.md. Okay, I mean, in terms of the planning phase, the research phase, doesn't seem anything too great about that, really. Yeah, so notice the language deeply in great details, intricacies, and go through everything. This isn't fluff. Without these words, Claude will skim. It will read a file, see what a function does at the signature level, and move on. You need to signal that surface level reading is not acceptable. Written artifact research.md is critical. It's not about making Claude do homework. It's my review surface. I can read it, verify Claude actually understood the system, and correct misunderstandings before any planning happens. If the research goes wrong, the plan will be wrong and the implementation will be wrong. Garbage in, garbage out. This is the most expensive failure mode with AI-assisted coding, and it's not wrong syntax or bad logic. It's the implementation, the work in isolation but break the surrounding system. A function that ignores an existing caching layer, migration doesn't account for ORM conventions, an API endpoint that duplicates logic that already exists elsewhere. The research phase prevents all of this. Yeah, so I was reading the actual the Hacker News thread actually, and I think there were some comments about this stuff. Maybe it's in. swear it was a critical thing. But yeah, I mean, the comment that I remember reading was basically saying that if you look at a lot of the Claude prompts that actual Claude Code uses itself, there's a lot of like critical, like rule 0, you must do this kind of thing. Because yeah, apparently it does often just skim stuff and miss a lot of the stuff. And thinking back to the way that we were working with Specify, maybe if Specify has these kind of keywords that make it go really looking into the actual intricacies of the documents, we might have started with TDD, we might have done DDD from the start, rather than me having to come back and say, hey, look, why haven't you followed these particular rules? Okay. So yeah, I think from my point of view, that makes a lot of sense. I definitely think the research phase is super important, actually, given what we've experienced. And coming up with this artifact is a good idea because we can review it and make sure that Claude is aligned with our thinking, rather than just saying, hey, look, go and attempt this particular thing. So phase 2, planning. Once I reviewed the research, I asked for a detailed implementation plan in a separate markdown file. I want to build a new feature name and description that extends the prompt to perform business outcome. Write a detailed plan.md document outlining how to implement this. Include code snippets. The list endpoint should support cursor-based pagination instead of offset. Write a detailed plan.md. How to achieve this, read the source files before suggesting changes based on the actual code base. Generated plan always includes a detailed explanation of the approach. Code snippets showing the actual changes, file paths that we modified, and considerations and trade-offs. I use my own .md plan files rather than Claude Code's built-in plan mode. The built-in plan mode sucks. The markdown files give me full control. I can edit in my editor, add in my notes, and it persists as a real artifact in the project. One trick I use constantly for well-contained features where I've seen a good implementation in an open source repo, I'll share that code as a reference alongside the plan request. If I want to add sortable IDs, I paste the ID generation code from a project that does it well and say, this is how they do sortable IDs, write a plan explaining how we can adopt a similar approach. Claude works dramatically better when it has concrete reference points to work from rather than designing from scratch. But the plan document itself isn't the interesting part. The interesting part is what happens next. Okay, yeah, so I think, again, from what we've seen, having some kind of artifact is crucial because we can review it, we can update it, and make sure that Claude is going to be on the right path. The annotation cycle. This is the most distinctive part of my workflow and the part where I add the most value. So Claude writes the plan, I review in my editor, I add inline notes, send Claude back to the document, Claude updates the plan. Satisfied? No, you repeat. You are satisfied, you end up with a to-do list. Okay. After Claude writes the plan, I open it in my editor and add inline notes directly into the document. These notes correct assumptions, reject approaches, and add constraints, or provide domain knowledge that Claude doesn't have. The notes vary wildly in length. Sometimes the note is 2 words, not optional, next to a parameter name, marked as optional. Other times it's a paragraph explaining a business constraint or pasting a code snippet showing the data shape I expect. Yeah, and having done some kind of I guess vibe coding with Claude just in the actual web UI, often I've had to give it kind of an output example or explain what I actually want in kind of pseudocode to get it to do what I'm actually requesting. Because often you'll ask it to do something and it will just spit out some random code, often like in a language that you're not expecting. I think it normally like defaults to JavaScript. And it's just really frustrating. Like I only use Python with Claude and yet it will keep spitting out JavaScript, stuff like that. And I think definitely the giving it code examples and snippets and the expected shape of the data is super important. Otherwise, it will just kind of do a subpar job from my experience. So it definitely seems like a sensible approach so far. Some real examples of notes that I've added. Use Drizzle generate for migrations, not raw SQL. Yeah. No, this should be patch, not put. remove this section entirely. We don't need a caching layer. The queue consumer already handles retries, so the logic is redundant. This is wrong. The visibility field needs to be on the list itself, not on the individual items. When a list is public, all items are public. Yeah, okay. So yeah, it's really kind of guiding a lot more than the current process that I've been using. Even with Specify, we haven't gone into this kind of detail. With Specify, it was just kind of generate it all up front, kind of assume that it's all correct, and then go with it. As we saw, it didn't really work particularly well. Then I send Claude back to the document. I've added a few notes to the document, address all the notes, and update the document accordingly. Don't implement yet. Yeah, I think this is a super important thing. Like, again, what I've seen with Claude is like you'll say, write a function to reverse a string, for example, and it will do that, but then it will just keep going and keep doing other stuff in your code that you haven't asked it to do, that it thinks it needs to do, that may not even be something you want in your code. So you really do need to be really kind of specific with this kind of stuff. Cycle repeats 6 times. The explicit don't implement yet guard is essential. Without it, Claude will jump to the code. Yeah, the moment it thinks the plan is good enough. Yeah, again, and I've seen this both in the UI and in Claude Code. So often in the UI, like I'll be just kind of like brainstorming with Claude, just trying to like flesh out an idea a bit, and I'll ask a few questions and just say, look, I'm just kind of brainstorming here, and then it will just spit out code, and you're kind of like, no, this is not what we wanted. We're in this kind of discussion phase, trying to work out exactly what's going on. Don't just write code that is out of context and just what you think I want from this small little prompt. Actually, let's kind of work together and come up with a decent plan and then implement it. So yeah, from my experience, the don't implement yet thing, again, is super crucial, which it shouldn't be, but it does seem like its default is, okay, I've got some input, let me just write code and just go and not stop until I'm told to stop. Why this works so well. The markdown file acts as a shared mutable state between me and Claude. I can think at my own pace, annotate precisely where something is wrong, and re-engage without losing context. I'm not trying to explain everything in the chat message. I'm pointing at the exact spot in the document where the issue is and writing my correction right there. Yeah. This is fundamentally different from trying to steer implementation through chat messages. The plan is structured, complete specification I can review holistically. A chat conversation is something I'll have to scroll through to reconstruct decisions. The plan wins every time. 3 rounds of I added notes, I added a plan, can transform a generic implementation plan into one that fits perfectly into the existing system. Claude is excellent at understanding code, proposing solutions, and writing implementations, but it doesn't know my product priorities, my users' pain points, or the engineering trade-offs I'm willing to take. The annotation cycle is how I inject that judgment. Yeah, again, totally agree with this. Again, from kind of what I've seen and how I've used Claude so far, you're kind of this much higher level kind of system architect and much more focused on the design of the system. And I kind of think of Claude as this kind of really enthusiastic kind of smart junior developer that just wants to get going and write all the code and do everything, but doesn't actually take a step back and kind of think of the overall architecture, the product itself. It just kind of wants to do stuff. And that ends up often leading down kind of the wrong path. So I do really think you need to be this kind of higher level guiding of Claude to get the best results. Not that I've managed to get anything particularly great so far with Claude. The to-do list. Before implementation starts, I always request a granular task breakdown. Add a detailed to-do list to the plan with all the phases and individual tasks necessary to complete the plan. Don't implement yet. This creates a checklist that serves as a progress tracker during implementation. Claude marks items as completed as it goes, so I can glance at the plan at any point to see exactly where things stand. Yeah. Again, this is kind of what Specify did, but as we saw, like even when you had like the first line, use TDD, it's critical you use TDD, and then it would just implement all the actual user stories and not do any TDD, and it just goes from like user story 1 to 3 to 4 without doing any tests. So Maybe this approach is better, but the similar approach for Specify didn't really work. So it'll be interesting to see how this kind of approach works. Phase 3, implementation. When the plan is ready, I issue the implementation command. I've refined this into a standard prompt I reuse across sessions. Implement it all. When you're done with the task or phase, mark it as completed in the plan document. Do not stop until all tasks and phases are completed. Do not add unnecessary comments or JS docs. Do not use any or unknown types. Continuously run type check to make sure you're not introducing new issues. Okay. Single prompt encodes everything that matters. Implement it all. Everything in the plan, don't cherry pick. Source of progress, yeah. Do not pause for confirmation mid-flow. Keep the code clean. I'm not necessarily sure that would keep the code clean, but yeah. Yeah, strict typing, catch problems early, not at the end. Okay, I mean, there's no mention of testing here, which seemed like a bit of an oversight. Maybe that's all included in the plan, or maybe this person doesn't write tests. I think they sold a company to Cloudflare or something, so I would assume they do testing, but maybe they just kind of missed it in the article and it's kind of included in the implement it all. I use this exact phrasing in virtually every implementation session. By the time I say implement it all, every decision has been made and validated. The implementation becomes mechanical, not creative. This is deliberate. I want implementation to be boring. The creative work happens in annotation cycles. Once the plan is right, execution should be straightforward. Without the planning phase, what typically happens in Claude makes a reasonable wrong assumption early on, builds top of it for 15 minutes, and then have to unwind a chain of changes. The don't implement guard eliminates this entirely. Yeah, I mean, that makes a lot of sense to me. I guess the only thing here would be, well, again, like testing's not mentioned, but if we skip over that, like how often do we get the implementation plan 100% correct up front? Maybe I'm just not a good software engineer, but it's often the case that I have to change the implementation plan a little bit as I'm writing the code. But maybe with Claude that doesn't happen. Maybe we spend a lot more time diving into it and we catch those things up front. Maybe. I guess we'll see. Okay. Feedback during implementation. Once Claude is executing the plan, my role shifts from architect to supervisor. My prompts become dramatically shorter. Okay, yeah, so again, he kind of sees it the same way that I do in terms of being the kind of architect up front, and then you kind of move towards this supervisor. Claude implements, I review tests, correct, no, yes. Terse correction, more tasks done, yes, okay. Where a planning note might be a paragraph, no, implementation correction is often a single sentence. You didn't implement the function. You built the settings page in the main app when it should be in the admin app. Move it. Claude has the full context of the plan and the ongoing session, so terse corrections are enough. Front-end work is the most iterative part. I test in the browser and fire off wrapper corrections wider, blah, blah, blah. For visual issues, I sometimes attach screenshots. A screenshot of misaligned tables communicates the problem faster than describing it. I also reference existing code constantly. This table should look exactly like the user table. Yeah. Far more precise than a design from scratch. Most features in a mature code base are variations on existing patterns. A new settings page should look like the existing settings page, pointing to the reference communicates all the implicit requirements without spelling them out. Claude would typically read the reference files before making the correction. If something goes wrong in a wrong direction, I don't try to patch it. I revert and rescope by discarding the git changes. Okay, I've read everything. All I want to do, right? Yeah, I mean, this is interesting though, because like he says that it just implements it all in one go. But this to me implies that like he does an implementation of something, he checks it, moves on, rather than implementing one specific feature, doing this phase, and then moving on. But maybe that's just me interpreting this slightly incorrectly. Okay. Staying in the driver's seat, even though I delegate execution to Claude, I never give it total autonomy over what gets built. I do the vast majority of the active steering and plan documents. This matters because Claude will sometimes propose solutions that are technically correct but wrong for the project. Maybe the approaches are over-engineered, or it changes a public API signature that other parts of the system depend on. I mean, that again implies there's no testing here, because that would, in theory, break the tests. Or it picks a more complex option when a simpler one would do. I have the context about the broader system, the product direction, and the engineering culture that Claude doesn't. Yeah, I mean, again, this kind of implies that you know what you're doing. If you have experience building software, you can do this. If you don't, then you're kind of screwed, basically, and you're relying on Claude to get it correct. So again, it's one of those things where it does seem that the more experienced you are at building software, the better results you will get out of these tools, which implicitly makes total sense, really. If you don't know how to code, then you're always going to run into problems because you don't understand what you don't know. So Claude proposes changes. I evaluate each change, either accept, modify, skip, or override the choice. Yeah. When Claude identifies multiple issues, I go through them one by one. For the first one, I just use promise.all. Don't make it overcomplicated. For the third one, yeah, I mean, this is just kind of, as it says, cherry picking, makes sense. Trimming the scope. When the plan is include nice to haves, I actively cut them. Yeah, I mean, is this not planning phase stuff? But yeah, we'll see. Protecting existing interfaces. I set hard constraints when I know something shouldn't change. The signatures of these functions should not change. Yeah. Override technical choices. Sometimes I have a specific preference Claude wouldn't know about. Use this model instead of that one, or use this library's built-in method instead of a custom one. Fast direct overrides. Claude handles the mechanical execution while I make the judgment calls. The plan captures the big decisions up front, and selectively guidance handles the smaller ones that emerge during implementation. I don't want to do hand gestures though. Thank you very much. Yeah, I mean, again, I guess this is in the I guess this is the implementation phase, but it doesn't quite make sense as to where this phase sits personally. But because again, this is in the plan document, but these things themselves make total sense to me. So yeah, I guess it's just in the loop of kind of Claude does think you look at the plan, you update the plan, tell it to do stuff, and keep going. Single long-running sessions. I run research, planning, and implementation in a single long session rather than splitting them in separate cross sessions. A single session might start with deep reading a folder, go through 3 rounds of plan annotation, then run the full implementation all in one continuous conversation. I'm not seeing the performance degradation. Everyone talks about after 50% context window. Actually, by the time I say implement it all, Claude has spent the entire session building understanding, reading files during research, refining its mental model during annotation cycles, absorbing my domain knowledge, corrections. When the context window fills up, Claude's auto-compaction maintains enough context to keep going. Plan document, the persistent artifact survives compactation in full fidelity. I can point Claude to it at any time. Yeah, I mean, I don't think I've personally witnessed a huge degradation when it hits 50%. Maybe I've not been doing anything too complex, so maybe that's why. But yeah, it definitely seems that the approach is you have to have these artifacts that you basically constantly refer to, which kind of makes sense, right? I mean, when I build software, the artifact is the code, right? And I go back to the code, I go back to the architecture document, the planning document, and I use that to kind of understand where I am, once I come back from, from lunch or whatever. Like, so it makes sense to kind of have this process. The workflow in one sentence: read deeply, write a plan, annotate the plan until it's right, then let Claude execute the whole thing without stopping, checking types along the way. That's it. No magic prompts, no elaborate system instructions, no clever hacks. Just a disciplined pipeline that separates thinking from typing. The research prevents Claude from making ignorant changes. The plan prevents it from making wrong changes. The annotation cycle injects my judgment, and the implementation command lets it run without interruption once every decision has been made. Try my workflow, you'll wonder how you ever shipped anything without coding agents, without an annotated plan document sitting between you and the code. So yeah, I think overall, like, a really interesting article. I will definitely try this approach because it does seem to be pretty good. In a lot of ways, it's kind of like Specify, but more hands-on and more kind of driven in the architectural system design side of things, rather than just kind of like, hey, give me a product spec, let's talk about it, okay, here's a plan, here's some specs, let's go build them, sort of thing, which is what Specify seemed to do. And Specify really fell down, as we saw, when we kind of have to deviate from that plan, or once we've done that plan and we want to build other features, it just kind of doesn't really have that workflow in it. So yeah, really interesting article, and we could definitely give this approach a go.